Hello, welcome to video 7. This is the last and final video to show you how to name organic compounds using IUPAC nomenclature. Now, if you've gone through all of the previous videos 1 to 6, you would have gotten all the rules for naming individual functional groups organic compounds. This slide shows the summary of nomenclature for the compounds you've learned. You've learned how to name the alkanes, alkyl halides, ethers, alkynes, alcohols, and amines. Now, when we put all this together, there's just one more thing you need to know. So far, we have talked about all the functional groups individually. But what happens when we mix it all up? That is, it is possible for many functional groups. Now, the last thing you need to know about how to name organic compounds properly is that the functional groups do have an inherent priority. That is, some functional groups have higher priorities to be parents before others. Now, in case you're wondering what this order is, we have actually covered the different functional groups in the approximate increasing order of their priorities, so that hopefully from videos 1 to 6, it is easier for you to remember the priorities that we have covered. Actually, there are 3 classes of priorities: Class A, Class B, and C. You will see that in Class A, we have covered the alcohols and the amines. The other functional groups in Class A we'll cover in the later course. In Chem 2441, these are the only 2 in Class A we have talked about. In Class B, we've already talked about both functional groups, which is the alkenes and alkynes. And finally, in Class C, we have the alkanes, alkyl halides, and ethers, which we also have covered fully. Now, what you need to know is that Class A has higher priority than Class B, which is higher priority than Class C. Now, what does that really mean when you come to name functional groups of molecules? If the functional groups fall across different classes, then the parent chain is determined by the highest priority class, and the lowest numbers are assigned to that highest priority class functional group. If it's within a priority class, except Class A, which we'll talk about last, the functional groups are equal in priority, so that we give the overall lowest possible numbers to all of the functional groups. Probably it's easier to illustrate by a few examples. Let's look at this particular compound. You can see that this is an alkane with just alkyl groups. So alkanes and alkyl groups are in the same class, namely Class C. Because they're in the same class, we give lowest overall numbers to all of the substituents. So if you look at this molecule, it is lowest to name this 1, 1, and then 2, so that the name is 1,1,2-trimethylcyclopentane, and not the alternative names because these give overall higher numbers. This molecule, besides alkyl groups, also has a halo group. However, alkyl halides and alkyl groups are in the same priority class, namely Class C. So we just give all of the substituents again lowest possible numbers. And if you think about it, the lowest possible numbers will be to give this 1, 2, 4. So that this compound is 4-chloro-1,2-dimethylcycloheptane. Notice that it's not 1,3,4 or 1,2,6, which are higher overall numbers than 1,2,4. Here is some examples of Class B compounds. Alkenes and alkynes are in the same class. And so if a molecule has both an alkene and an alkyne, we assign numbers so that the overall functional groups, either the alkene or alkyne, would have the lowest numbers. Let's look at this molecule on the left. In order to give the lowest numbers to either of these functional groups or the overall functional groups, we name this 1, 2, 3, 4, 5, 6, 7, so that the carbon of the triple bond and the carbon of double bond would get the numbers 1 and 5. However, if we name across this way, 1, 2, 3, so it's 2, 4, 5, 6, it will be 2 and 6. Now, 1 and 5 is lower than 2 and 6, so that's why this is the correct name of this compound. Now, we just swap the positions of the double and triple bonds so that now the first carbon is the one having the carbon-carbon double bond, and then 2, 3, 4, 5. 5 is the carbon having the triple bond. And in this case, the correct name is 1-heptene, 5-ine. Notice we just care about getting the lowest possible numbers, 1 and 5 in this case. It doesn't matter whether it's going on the alkene or the alkyne, simply because 1,5 is less than 2,6, so therefore this is the correct numbering and name for this compound. Now for this final compound, whether we name from the left to the right or the right to the left, the same numbers occur for the carbon-carbon double bond as well as the triple bond, that is 1 and 7. In this case, either we name it, the numbers are still 1 or 7. So in this case, you give 1 to the double bond because E for the ene comes before ine. So it's oct 1-ene, 7-ine. Now let's talk about polyfunctionalized compounds having functional groups from different classes. For example, this particular compound. Here we have two functional groups. OH, that means it's an alcohol, and also here, this is an ether, right? ROR. Now, alcohols belong to class A, and ethers belong to class C. So, class A, the alcohol, has higher priority than an ether. So, we pick as the parent chain the longest functional group containing the OH group. So that means it is this 1, 2, 3 carbon compound containing this OH, and so we name this as a derivative of propanol. Notice that even though this has 1, 2, 3, 4 carbons and would be the longer carbon chain, but because it belongs to a lower class functional group, we do not put this in priority. The priority goes with the higher priority functional group and the longest chain belonging to it on which it's situated. So that's why this is a derivative of propane 1-ol. It's 1 because we want to give the alcohol the lowest possible number. So we don't name this 1, 2, 3, for example. So after we give the OH carbon 1, it means this group here, the butoxy group, is a substituent on carbon 3. So it's 3-butoxy propane 1-ol. Notice how deciding that we have a class A priority group determines which is the longest carbon chain attached to this functional group, and also the numbering that gives this OH group the lowest possible number. Here we have a bifunctional organic compound that is an amine as well as being an alkyl bromide. Amines belong to class A, and haloalkanes belongs to class C. So the amine has higher priority than the bromide. So that means we search out the longest carbon chain bonded to the amine as the parent chain. In this case, just one carbon, this is short. But for this, it is on a 5-carbon chain. So therefore, it is a derivative of pentamine. Now, we number the chain so that it has the lowest numbers assigned to this amine functional group. That means it's 1, 2, 3, 4, 5, giving number 2 to the amine group. So that's why it's a pent-2 amine. We name the rest of the amine NN-dimethyl pentamine. And finally, we also add the 4-bromo group. 4-bromo NN-dimethyl pent-2 amine. Now this last example is an alcohol as well as an alkene. So an alcohol, class A, has a higher priority than alkene, which belongs to class B, and so the compound is named as a derivative of an alkanol. And we name the alkanol so that the OH group has the lowest number. So that this is a hex 5-ene 3-ol because we named this 1, 2, 3, 4, 5. 5 is the amine. So hex 5-ene 3-ol. We do not name it hex 1-ene 4-ol, even though 1 is smaller than 3, the first number that comes. This is because by naming this as a derivative of the class A functional group alcohol, we have to also give the functional group the lowest possible number. So 3-ol is lower than 4-ol. Now finally, we said everything except class A. So what is special about class A? Well, within class A, the functional groups increase in priority like this, so that the amine has a lower priority than alcohol. There are functional groups having higher priorities than alcohol, but we have not covered them in Chemistry 2441. So it suffices for this class to know that OH always gets a lower number than NH2 because OH always has a higher priority than NH2. So in this left-hand molecule, you see that the alcohol has higher priority than the amine. So we number this 1, 2, 3, 3 alcohol, and it's a 6-membered alcohol, so it's a hexane 3-ol. And then, of course, the amine gets number 6. If we swap the places of these two groups, which gives us this molecule, now it, of course, is still a hexane molecule, but now we give OH the lowest possible number so that we now name the chain starting from this end, 1, 2, 3, 4, 5, 6. So it's a 4-amino hexane 1-ol. Notice in both cases, we give the lowest number to the higher priority OH group. Now there you have all of the IUPAC rules so that you can name all the functional groups you're going to cover in Chemistry 2441. Now the next step is really getting all of this together, because these rules should apply to all kinds of molecules, and you need to be careful not to be tricked by the way the molecules are drawn or getting the priorities mixed up along the way. The best way to do this is to get enough practice, and this is why we've designed the online drill so that you can actually generate an infinite number of drills if you want to, and get enough practice until you've learned all the rules. Nomenclature is a basic skill you need to begin learning and talking about organic chemistry. So after learning it through this drill, you will be assumed to know how to do it for the rest of this course. This is the end of all the videos showing you how to name organic compounds. Now you're ready to begin the online Moodle drill.